In this video, I'm going to explain how to graph inverse trig functions. And first inverse trig, we have an inverse sine function, inverse cosine function, inverse tangent function. So the way we start is basically doing a regular sine. So on this grid that you're very familiar with, I'm going to put a regular sine function. So uh, we have a point here at 0, 0, at pi over 2, 1, at pi 0, at 3 pi over 2 negative 1, and at 2 pi back to 0. And of course that's a regular sine, and of course we could repeat this on the left side from negative 2 pi. We just copy the same points again. Okay, so when we want to do a inverse trig function, we have to restrict the domain. Okay, otherwise, if we don't restrict the domain, we're not going to have a function, and we like to have functions. Okay, so for the inverse trig function, inverse sine function, we're going to restrict our domain from negative pi over 2 to pi over 2. Okay, and after we graph it, we'll probably see why. So we're basically going to cut our trig function down to basically this little area right there. Okay, so what I'll do is I'm going to actually blow that up. Okay, so I actually took that little section right there and blew it up. So let me graph that again. A regular sine function will look like this. At 0, our first point is at 0, 0, and at pi over 2, we go up here to positive 1, should be about there, and at negative pi over 2, negative 1. Okay, so this is just a portion of a regular sine graph, okay, that's blown up. Let's try to find green. Okay, so when we do an inverse function, and let me, before I actually graph this, let me do a little input-output table. Okay, so here's our x, here's sine of x. Okay, so I'm going to pick as my input negative pi over 2, and then 0 and pi over 2, positive pi over 2. Now there's lots of values other than positive and negative pi over 2. There was um, between 0 and positive pi over 2. Commonly on the unit circle, you'll see a pi over 6, you'll see a pi over 4, you'll see a pi over 3. And we could actually include that in the input, but it's really just going to just create extra stuff that, and our answers are going to be things that we just can't see as well. These values that I picked, negative pi over 2 and pi over 2 and 0, these are going to have easy values because the sine of 0 is 0. The sine of a positive pi over 2, remember at the unit circle, okay, here's 1, 0 over here, and here's 0, pi over 2 is at the top, and negative pi over 2 is down here at the bottom, and the coordinates here are 1, 0, up here is 0, 1, and the coordinates down here are 0, negative 1, and all these values in here have square root of 3 over 2, and or square root of 1 over 2, or square root of 2 over 2. So that's why I'm avoiding those values in case you're thinking on that. Okay, so here's my 0. That's my x value. My sine value is the second coordinate, which is, so my sine is 0 is 0. At pi over 2, it's at the top here. My unit circle value is at positive 1. Okay, and at negative pi over 2, my sine value is negative 1. Okay, so when we actually want to graph an inverse function, we actually change over our domain and range. Okay, the negative pi over 2 and the 0 and the positive pi over 2, that's our domain for regular sine, and the negative 1, the 0, and the 1, that's our range. for the functions. All right, when we do inverse sign, we change them. I actually put the -1 and the 0 and a 1 on the left side, and I call that my x. And our inverse sine of x, our answer would be for -1 a negative pi over 2, for 0 still 0, and for 1 a positive pi over 2. Okay, so really if I know that and I just pick those three numbers, and then my graph, now what I did with my graph here, my grid, I took this grid right here. Okay, I blew it up, as you can see. I took this grid. You got to use your imagination, guys. I can't really show you too well. I turned it 1/4 turn that direction, which is clockwise. Then you flip it upside down. Okay, so this negative pi over 2 all of a sudden came up to the top, and this 1 right there went over there, and this positive pi over 2 went down the bottom, this -1 went over here. Okay, and then I'd have a positive pi over 2 on the bottom and a negative pi over 2 on the top. My 1's wind up really well. My -1's on the left and my positive 1's on the right. Now if I flip it upside down, now I have what I really want over here. I have my positive pi over 2 at the top and negative pi over 2 on the bottom. I have my -1 on the left, okay, and my positive 1 on the right. So it might be tough to kind of imagine it, but that's what really happens. If you can imagine taking this grid on the left and turning it 90 degrees clockwise and then turning it upside down, now we have a grid we can put an inverse sign on. Alright, so what are my values? Okay, so this is still my x-axis, and this is now my y-axis. Okay, so it flipped the x and y axis on my original function up around. So at -1, let me change that to blue. My x is -1, which is right there. My y value is negative pi over 2, so I'll put a point down here. -1, negative pi over 2. 0, 0 is at the origin. Okay, and when you get positive 1, I go to positive pi over 2. So your inverse sign looks good, and you have to, it looks like this. Let me make it a little bit thicker. Kind of curves like that, and it curves like that. So how do I know which way it curves? All right, here's a quick way. Go back to your regular sign. Okay, I'm going to do a quick little, see these gray marks, right? These little gray X's. I do a dashed line right there. Cover them. Let me do it with see it better. Okay. Let's see, I'll do a red line. I'll make that dashed. Let me try one more time. Okay, let me pick a dashed line. Okay, that red line I just drew is y over x. And if you look real careful, see how this the regular sign in green curves up like that? Well, if it's an inverse function, it just curves the other way. It would actually curve down like that if you flip it across. So that tells me I know how this curves like that. It curves up like that. Of course, this is the opposite. Okay, so that is an inverse sine function. Okay, now I'm going to go to, let's try inverse cosine. Okay, now inverse cosine will have to do a little bit different. Okay, so I'll do a regular cosine. A regular cosine, okay, has points at 0, 1, pi over 2, 0, pi -1, 3 pi over 2, 0, 2 pi 1. Okay, so that's one cycle or one period of a cosine. Of course, I could do another one on the left. Okay, it's good practice to do. Okay. Alright, so I'm going to restrict this one also, but it's going to be a different restriction. Okay, I'm going to cut my, I'm going to restrict it right here. Let me try that again. I'm going to use from here to here, that little box right there. Okay, because from there, from pi to the right, it cycles over again. That's why you have to restrict the domain, because trig functions cycle over and over and over. So let me blow that up for us. Okay, so the domain is going to be restricted from 0 to pi this time. Alright, for inverse cosine, the domain is restricted this time from 0 to pi. Not from negative pi over 2 to positive pi over 2, but from 0 to pi. Alright, so let me blow that up. So at 0, the cosine is 1. Okay, at pi over 2, the cosine is 0. And at pi, the cosine is negative 1. Okay? So here will be our graph of a regular cosine. Okay, not the inverse cosine. Okay? Alright, what was the, okay, let's do a little t-chart of that. Okay, let's see. So x, cosine of x. So I pick 0, and I pick pi over 2, and I pick pi. Again, I'm going to avoid using the pi over 6, pi over 3, pi over 4. Those values, of course, are good to know on a unit circle, and definitely, to learn them. But for purposes of doing graphs of inverse trig functions, these are the best, because we get easy values. Alright, at 0, cosine is 1. At pi over 2, cosine is 0. And at pi, cosine is negative 1. Okay, so we want to do inverse cosine. So again, if you can see how it's changed, I took that cosine function, I turned it to the right. So let's do a little example here. Here's kind of like a mini little cosine. See how that's really long right there? You turn it to the right, and so now it would look kind of like, and here's pi over 2 and here's pi. Okay, so so I turn it to the right, it looked like this, and then you flip it upside down. Okay, so now the x-axis down here, and you got pi and pi over 2 and pi up there. So this is pi over 2, this is pi, and of course this would be 1 and this would be negative 1. You turn it to the right 90 degrees, so now your y-axis is really, I call it a y-axis, but now it's going to be our x-axis. Our y-axis, let me make the y-axis red over here. So that one now becomes this one. Okay, so I say y, but it's really going to be our x-axis now. And okay, so our pi over 2 wind up right there, and our pi wind up right there, but we don't have positive numbers on the bottom, so we flip it upside down. So our pi over 2 is going to be right there, and our pi is going to be up there. Okay, so hopefully that helps. So let's do a quick little, get this off. Let's do a little t-chart. Okay, so I picked very strategically the points for regular cosine. So for my inverse cosine, I just reverse them. I'll put the 1 and the 0 and the negative 1 on the input side, and the 0 and the pi over 2 and the pi on the output side. So how we graph it? Okay, okay, this is a negative 1 right here on the left on our new x-axis. This is a positive 1. Okay, so at positive 1 we get a 0. So our point starts right there. Okay. At x equals 0, we got pi over 2. Okay. And at -1, our answer is way up here at pi. Okay, so which way does it curve? Okay, let's see. Let's try figure out use our little trick before. Okay, if I do, y equal x. Okay, it's hard to see, but look, if we kind of flip this green area right here, okay, reflected across that axis, we'll get kind of goes up. Alright, it goes kind of like this. Alright, so how does that look? Let's see, the hardest part is the curve. Okay, let's do it like this. And sometimes some things you just have to try to memorize, and I'll redo, I'll look that up, make sure I'm doing the curve right. Alright, I'm pretty sure that's right. Okay, so let's go to inverse tangent. Finish up with the inverse tangent. Okay, so this is another restricted domain. This will be just like sine. Okay, the restricted domain is from -pi over 2 to positive pi over 2. So we'll do a tangent over here. Remember, tangent is sine over cosine. Okay, tangent of x is sine of x over cosine of x. Okay, so I want to do a real quick let's see, 0, pi over 2, pi, 3 pi over 2, and 2 pi over 2 and 2 pi. Let's see our sine and then our cosine. Okay, so these are unit circle answers again. At 0, sine is 0. At pi over 2, we get a 1. Pi is 0. 3 pi over 2 is a -1, and then 2 pi back to 0. The cosine of 0 is 1. Cosine of pi over 2 is 0. At pi is -1. 3 pi over 2 is back to 0. And at 2 pi back to 1. Okay, so tangent is you divide. 0 divided by 1 is 0. Okay, so let's put a point at 0, 0 for our tangent. Alright, now when we try to do our next point, sine divided by cosine, 1 over 0, well, that's undefined. So we have an asymptote at pi over 2 when we're graphing tangent. Okay, and the rest of it is pretty easy. We just go back. Every other point is a 0. 0 divided by -1, that's a 0. Okay, the next point is going to be a pi asymptote. So at 3 pi over 2, there's another asymptote. Okay, and then at 2 pi, there's another point of 0. This is just a regular tangent. Okay, in the first quadrant, the tangent zooms up. Okay, and then everything else alternates. This part goes down, then the next part goes up. This part goes down. And of course, we could copy it on the left. Put a point here, a point there. Asymptotes in between. -3 pi over 2 and -pi over 2. Okay, and it just copies again. This part of the graph will go up. This next will go down. This next will go up. This will go down. So that's 2 cycles. Well, that's really 4 cycles of a tangent graph. The periodicity of a tangent graph is only pi, not 2 pi like sine and cosine. But where are we restricting it to? We're going to restrict between -pi over 2 and positive pi over 2. So that's what we're going to use. Okay, so let me get rid of this little graph to help me do tangent. Okay, so let's blow up the regular tangent. Okay, so we have a point at 0, 0, 0. Okay, and now at pi over 2 we have an asymptote. Okay, so try that one again. All right, I'm putting at 1. I'm sorry, not at pi over 2. Let's go to pi over 2. Sometimes these gray lines are distracting. They're supposed to just show you that pi over 2. You know, here's that gray line really is x equal 1, and so pi over 2 is about 1.57, so on. So that's why I'm showing that. All right, but let's see. At negative pi over 2, there's another asymptote. Okay. All right. So what's going to happen? Okay, if I blow this up, what's going to happen? A regular sine, regular tangent. It sweeps up like that, gets close to the asymptote but never touches, and it sweeps down here. Okay, so let me do a little miniature t-chart for that. Okay, so when we pick x and tangent x, all right, a little more complicated because I'm trying to pick 0. Let me start with negative pi over 2. Negative pi over 2 and 0 and pi over 2. Okay, tangent of 0 is 0. Okay, so but at negative pi over 2, the tangent's undefined. And it's kind of, you know, I don't really see that. I look up somebody else doing that. I don't really see people making a chart there. But I'm going to put undefined. In fact, I'm going to put a little negative infinity, because as it gets close to negative pi over 2, the graph is going down forever. Okay, at positive pi over 2, it is also undefined, but I'm going to put a little positive infinity there. Okay, so how do we do our inverse tangent? Okay, so I think I'll put it down below here. So the same idea. Our x, our inverse tangent. So it's kind of odd to put undefined, but I'm going to try it. I'll put negative infinity for that one, and 0, and then the other undefined, positive infinity. So this really is standing for negative pi over 2. That's 0. That's positive pi over 2. All right, let's do the easy point first. Okay, 0, 0. Okay, so on the inverse tangent, a point right here in the middle at 0, 0. Okay, now at negative pi over 2, that's actually, see the red, the asymptotes actually also turn also. Okay, it's probably, you can probably see it really now if you think about it. I'm going to put an asymptote here at positive pi over 2. You know, that goes with the vertical red asymptote at positive pi over 2 in the tangent of x. And I'll put one also here at negative pi over 2. Okay, what's going to happen? Okay, between this 0 and this is negative pi over 2. Here's 0 and negative pi over 2. Okay, we're going to negative infinity. Okay, so what's going to happen is the curve will go swoop down like that. Okay, and above will boot it to the opposite. It'll sweep up like that. So that's an inverse tangent. Okay, so these are graphs we don't do very often. Okay, because it's kind of challenging. I won't say difficult, challenging to come up with the domain and range. It takes a while. So the best way is to practice. Okay, so I'm just going to do a real quick one. Okay, all right, sine of x, inverse sine of x, inverse cosine of x, inverse tangent of x. Okay, We just done inverse tangent. So, okay, negative pi over 2, pi over 2, positive pi over 2 goes through here. Here's an asymptote. Here's another asymptote. Sweeps up like that, sweeps down like that. Alright, inverse sine. Okay. Alright. So positive pi over 2 was up here. Negative pi over 2 was right down there. This was negative 1. This was positive 1. And if you remember right, it went like this. That was inverse sine. Now inverse cosine. Okay. The x-axis down here somewhere. So that's the x-axis. That's the x-axis. Alright. Down here, and here was your positive pi over 2. And here was your pi. Okay. Here was negative 1. Here's positive 1. And we didn't care about any of that down there. Okay. So this one went the opposite way. Okay. You had a point there, there, and there. And it sweeps the other way. Okay. So best advice is do little, practice those by hand. Okay, but you do have to see the good examples, of course, looking up nicely done on the internet or using your graphing calculator will do great also. But that's how you do inverse trig functions.